Okay, so in this video I'm going to have a look at the basics of probability, and I'm going to go through these particular terms here. I'll go through them one by one as we go along. First one that I'm going to have a look at here is called a trial, and a trial is just the act of doing an experiment in probability. So for example, if you roll a die, that's just a trial. Now an outcome then is the it's one of the possible results of a trial, I guess. So for example, if you flip a coin, one of the possible results would be a head, another possible result would be a tail. So they're just called outcomes. An event then is the occurrence of one of these outcomes. So for example, if you roll a die and get a 5, that's called an event. Probability itself is just the measurement of the chance of an event happening. So we would generally use either the likelihood scale or the probability scale. I'll go through those in a few minutes. Sample space is all the possible outcomes. It's just all the possible outcomes that can happen when you carry out a trial. So for example, if you flip a coin, the possible outcomes would be head or tail. There are no other possible outcomes. So this here would be your sample space for flipping a coin. If you roll a 6-sided die, all the possible outcomes would be 1, 2, 3, 4, 5, and 6. So this here would be your sample space for rolling a 6-sided die. Now, when we look at these two, I'm going to have a look at these two particular scales here. One is called the likelihood scale and the other is called the probability scale. The likelihood scale is just the the probability scale in words, if you like, in English. So we go from impossible to unlikely to evens to likely and then to certain. So we've everything covered here. We're going from impossible here right up to certain and everything in between. Now they're fairly general terms and they're open to interpretation really, but you can use any of these words when talking about probability if you're asked a question and asked to give your answer in terms of the likelihood scale. So for example, if we flip a coin, the probability of getting a tail would be evens on the likelihood scale. The probability that the sun will rise tomorrow, I would say certain. The probability that it won't rise tomorrow, impossible. And then you've got unlikely and likely as well. The chances or the probability that it will rain tomorrow. Again, it depends on where you live, but I would say here it would be likely. If you live maybe in a sunny country, maybe you would say it's unlikely, and so on. So it's kind of a little bit loose in terms of its interpretation. So there is another scale then called the probability scale, and that scale goes from 0 to 1. So we would just simply draw a line, if you like this, and we would say that down here we'll have 0, and up here we'll put a 1, and in the middle here I'm going to use decimals here, so I'm going to say this is 0.5. So it's very similar to this scale up here. 0 is impossible, 1 is certain, and then 0.5 is evens. And so you can actually measure things in terms of actual numbers here rather than words. So again, for example, if you flip a coin, the probability of getting a tail, usually you would write P for probability and then what you're trying to find the probability of in brackets after it, and then write the answer here, 0.5. The probability of getting let's say a 2 when rolling a die is 1/6, because there are 6 numbers on a 6-sided die anyway, 6 numbers, 1, 2, 3, 4, 5, 6, so the probability of getting one of those is 1/6. Okay, so that's our two scales here, likelihood scale and probability scale. Now I'm going to run through these 3 types of probability here. We've got theoretical probability, relative or experimental frequency, and we have expected frequency as well. These are kind of frequencies rather than probabilities as such, but you can use them as probability. We'll see in a second anyway. I'll show you exactly how they work. Theoretical probability is the first thing here, and I've already done that to a certain extent here. I've said that when you flip a coin, this here is theoretical probability. This is theoretical probability here. When you flip a coin, the theoretical probability of getting a tail is 0.5, assuming the coin is a fair coin, that it's not weighted on one side. And same with a die. If you roll a die, if it's a fair die, if it's equally balanced, the probability of getting any particular number, the theoretical probability of getting any particular number, is going to be 1/6, 1/6, because there are 6 numbers. That's your theoretical probability. Now, relative or experimental frequency is what I'll just have a quick look at now. So we're going to have a look at relative frequency. And it's also called experimental frequency because you're carrying out an actual experiment here. Now, it's really given by the frequency or the number of times an event happens. The number of times an event happens when you carry out a trial, divided by the total number of trials. Total number of trials. So what does that mean? Well, for example, if you ask, let's say, 1,000 people, we'll ask 1,000 people what kind of music they like. So we're going to ask about music, okay? And we're specifically interested in, let's say, classical music, okay? So we ask 1,000 people, do you like classical music or not, okay? And let's say that 430 people like classical music. So what we would then say is that our relative frequency, or our experimental frequency, for this particular trial here is 430 divided by 1,000, or just simply 0.43. So we asked 1,000 people, what kind of, do you like classical music or not? And we found that 430 people do like classical music. So our relative frequency for people who like classical music is 430 divided by 1,000. So this is called relative frequency. Now, the next thing I'm going to have a look at is what's called expected frequency. Oops. Let's do that again. So if we take our music example up here, we asked 1,000 people, do you like classical music? And we found 430 like classical music. So 430 divided by 1,000, or 0.43 of the 1,000 people liked classical music. That was our relative frequency. Now our expected frequency, then, we can possibly use this. So what we can say is that if we go out again and say ask another, let's say 2,000 people. So I'm going to go out and ask 2,000 people do you like classical music? How many people would I expect to like classical music? And we can use this to determine that. So what I would do is just simply multiply that by 0.43, and that will give me my expected frequency. How many people I would expect out of this 2,000 people, how many people I would expect to like classical music. So that's going to be 860. Now, so just to recap on this, because these two tend to, people do tend to get these mixed up, like relative frequency and expected frequency. Relative frequency or experimental frequency is where you actually carry out an experiment and you get a result here. You divide the number of people, in this case, who like classical music, divided by the total number of people you asked. That gives you a relative or experimental frequency of 0.43. If then you decide to go out and or get someone else to sample another 2,000 people, how many people would you expect to like classical music? You use this relative frequency result that we got here. You just simply multiply your 2,000 by 0.43 and you get 860. So you haven't actually carried this out yet. You're kind of trying to predict how many people you would expect to like classical music. Now you can also use theoretical probability. If you don't have relative frequency, you can use the theoretical probability to work out expected frequency as well. So for example, if you decide you're going to roll a die, or no, let's say we'll go with the rolling the die one. Say for example you're going to roll a die. So we're going to roll our die, and we're going to roll it, let's say 500 times. Now what would be our expected frequency for getting let's say a 4? So we want to know how many times would you expect to get a 4. So remember, we haven't carried out the experiment. We're trying to predict how many times we would expect to get a 4. Now we haven't done an experiment, so we have no relative frequency that we can use. All we've got is our theoretical probability. Now the theoretical probability of getting a 4 is 1/6. Because there are 6 sides on our 6-sided dice numbered 1 to 6, the probability that any particular number is going to crop up when we throw the dice or roll the die will be 1/6. So the probability of getting a 4 is 1/6. We know we're going to roll the die 500 times, so we just simply take our 500, multiply it by 1/6, 1 over 6. So it's just 500 divided by 6, and we'll get 83.3. So we'll just round that to the nearest whole number, 83 there. So if we roll our die, if we know we're going to roll our die 500 times, we would expect to get a 4 83 times. In actual fact, it would be the same for any number on our die, because they all have an equal chance of turning up when we roll a die. So the expected frequency for getting a 2 would also be 83. The expected frequency for getting a 1 would also be 83, and so on. Okay, so that's it for just the very, very basics of probability.